Hello everyone. Today we're going to introduce an interesting method for testing the sensitivity of bacteria to antibiotics, called the Kirby-Bauer disk diffusion method. You may not be familiar with this method, but let's start with the basics of the disk diffusion method. Originally developed in the late 1940s to early 1950s, the disk diffusion method was initially used to assess the sensitivity of bacteria to antibiotics. The principle of this method involves placing paper discs containing known concentrations of antibiotics onto the surface of a culture medium containing microorganisms. By observing the diameter of the zone of inhibition formed around the discs, the sensitivity of microorganisms to the antibiotics can be evaluated. However, factors such as the choice of culture medium, the size of the discs, and the concentration of antibiotics varied until Kirby and Bauer proposed a standardized method in 1966, which is known as the Kirby-Bauer disk diffusion method that we are going to discuss today. First, let's address the issue of the culture medium. The Kirby-Bauer diffusion method typically uses Muller-Hinton agar as the culture medium. This standardized formulation contains casein hydrolysate, starch hydrolysate, acidified casein, magnesium sulfate, and agar. It provides nutrients for bacterial growth, regulates pH, and inhibits excessive bacteria growth. Its reproducibility ensures the accuracy of experimental results. Now, let's culture fresh and pure bacteria. Transfer the seed culture or the test sample to the culture medium and incubate it at 95 degrees Fahrenheit for 16 to 18 hours. After the specified time, use a sterile loop or swab to pick several isolated colonies from the overnight culture. Then suspend these colonies in sterile water and mix the suspension evenly using a vortex mixer. Measure the density of the suspension using a densitometer. Our goal is to obtain a suspension with a density of McFarland 0.5. If necessary, we can add more bacteria. Once we have standardized bacteria, we can evenly spread them on the entire surface of the Muller-Hinton agar plate using a swab. Again, ensure the freshness and thickness of the agar medium, which is typically required to be 4 millimeters thick. Repeat the streaking process to ensure uniform colony distribution. Now, we can place the antimicrobial discs. These discs are usually 6 millimeters in diameter, providing enough space for the antibiotic solution. Depending on the requirement, we place a different number of discs, typically between 3 and 6 on the plate. Pay attention to their relative positions to avoid overlapping inhibition zones. The next step is to incubate the plates. We place the plates in a constant temperature incubator at 95 degrees Fahrenheit and incubate them overnight. The following day, we can easily observe the differences. Using a ruler, measure the diameter of the inhibition zones in millimeters on the backside of the plate. Consult the CLSI guidelines to determine whether the microorganism is considered sensitive or resistant based on the measured value. We will continue to discuss the interpretation of CLSI guidelines in detail. The Kirby-Bauer diffusion method is useful for drug selection, monitoring antibiotic resistance, and researching and developing antibiotics. It is simple and easy to perform, requiring minimal complex equipment and technical expertise. The method is visually interpretable as the formation of inhibition zones is observed to determine bacterial sensitivity to antibiotics. It has broad applicability, allowing testing of multiple types of antibiotics across different bacterial species. One of its key advantages is standardization and speed, as the method follows strict operational and interpretive standards, ensuring comparability of results and providing results within 24 hours. However, it does have limitations. The Kirby-Bauer diffusion method can only provide preliminary sensitivity information of bacteria and cannot determine optimal therapeutic dosages or assess mechanisms of antibiotic resistance. Nevertheless, we will continue to introduce more advanced techniques. Stay tuned for more relevant content, and thank you for watching.